This is the Unit 2, Topic 2 Semester Exam Review for Algebra 1A. Again, I'm going to remind you about all of the formulas that are presented in the beginning of the exam. This is actually the topic that are going to use these the most with the arithmetic, geometric, equations of lines. So definitely keep this in mind as you go through it. The compound interest formula, the exponential function, that's all topics that are in Unit 2, Topic 2. Now remember, the exam won't be segregated by topics, but it's important to remember that you've got these formulas here so you can use them without having to memorize them. It's just important that you know how to use them because these will not be explained beyond what you see right here, right now. Question number 32. Callie makes a $60,000 starting salary at her new job. She is offered two different options for salary increases. Option A, an increase in salary of $3,000 per year. Option B, an increase in salary of 3% per year. Let the function a of t and b of t represent her salary after t years using options A and B respectively. So part A wants us to complete the tables for each option. So starting with option A, we see that that's an increase in salary of $3,000 per year. So what we're really doing is we're adding $3,000 every time, and that will be our option A. So 60,000 plus 3,000 is 63,000. Then we have 66,000, and then plus 3,000 is $69,000. So there's our option A. Option B is B of t, which is $60,000, but we are doing an increase in salary of 3% per year. So it's very important to remember that we're doing percent. Percent is always written as a decimal. So we're going to start with, for when t equals 1, we have 60,000 times 0.03. And when we multiply these together, we get $1,800. So that's what it's being added by. So we've got our original amount of 60,000 plus 1,800, and that's going to give us a total of 61,800. All right, when t equals 2, we're taking our amount of 61,800 and multiplying it by 0.03. When we do that, we get $1,854. So we have 61,800 plus 1,854, and what that equals is $63,654. So $63,654. So if you do that again for t equals 3, we have 63,654 times 0.03. Move this down a bit. And that's going to equal $1,909.62. So we're going to add that to $63,654 to get a total of $65,563.62. So we'll fill that in, $65,563.62. Another way to look at this is if you think about with percentages, that since I'm adding by 3% per year, what I'm really taking is multiplying by 100%, which will just give me the same amount every time. That's multiplying by 1, and then multiplying by 0.03. So what I'm actually doing is multiplying by 1.03, or 103%, because I'm increasing by 100%, which means staying the same amount, plus that extra 3%. Either way will work. I wouldn't worry about it. I think that students have trouble figuring this out originally they are able to figure this out after finding these numbers, but it doesn't matter. Any way works. All right, part B says complete the recursive rules for each option. So option A, and they've even started you off here. They've told you that A of 0, and you would figure that out. And from looking at the chart, we know that that's $60,000. That's also going to be the same for option B, because our starting amount is $60,000. With option A, what we're doing is we're increasing by $3,000 a year. So what I actually am going to have is A of t equals the previous term, which is A of t minus 1, and then I'm adding $3,000 to it. With option B, because we are increasing by percentage, this is going to be geometric. So what I have is the original amount, B of t minus 1, that's the previous term, and I'm multiplying it by 1.03. So 1.03 times B of t minus 1. And if you are struggling to figure out what this number is, just take this term and divide it by this term and see what it equals. Then this term divided by this term and see what it equals. And this term divided by this term and see what it equals. And if you get the same number every time, that tells you you're multiplying by that number. So it's geometric, and that is your common ratio. Just like you can figure out this number minus this will give you 3,000. And this minus this will give you 3,000. And this minus this will give you 3,000. And that tells you that you are adding by 3,000 every time, and therefore it's arithmetic. Part C says write an explicit rule for each option. So for option A, A of t, remember that common difference is what we multiply our variable by. So I'm going to have 3,000 times t, and then I'm going to add the initial amount. So 3,000 t plus 60,000. In option B, we have the starting amount, which is 60,000, times the common ratio to the power of t. Remember, you've got those formulas that are given at the beginning to help you. So this is our initial amount, and this is our common ratio, or our common difference. Finally, for question D, or part D, make a sketch of the general shape of the graph of her salary with each option. So with option A, they want to sketch. So I'd say, let's say 60,000 starts right here. And then with an increase of 3, we know that, or 3,000, we know that it's going to make a straight line. So something like that. With option B, let's say we started 60,000, and then it went up, 61,800. And it's going to go up a little bit more every time, and we're going to see that we're going to get more of a curve-like shape rather than a straight line. And those are your general shapes of the graphs. For question 33, it said look at the sequences below. Look at the 3 sequences below. Sequence 1 has f of 0 equals 45 and f of n equals f of n minus 1 minus 4. Sequence 2 has f of n equals 45 minus 4n. And sequence 3 has 45, 41, 37, 33, 29, and 25. Which of the above sequences are arithmetic? If we look at sequence 1, what we see is this, we have our first term and then the previous term minus 4. This is our recursive rule for an arithmetic sequence. And we know this because of the minus 4. Because it's adding or subtracting right there, that tells us it's arithmetic. For sequence 2, we have 45 minus 4n. This is actually going to be, and if we look at our sequence 1, we have our starting amount right here and our common difference of negative 4. So starting amount and then the common difference times n. So this is going to be our explicit rule for arithmetic. So we know that sequence 1 and sequence 2 are both sequences for arithmetic. Finally, to look at sequence 3, we're going to see what happens in between each of these numbers. So if you see 41 minus 45, what you notice is that that's going to give you negative 4. And then 37 minus 41 is going to give you negative 4. 33 minus 37 is going to give you negative 4. 29 minus 33 is going to give you negative 4. And 25 minus 29 is going to give you negative 4. Meaning that 45 minus 4 is 41. 41 minus 4 is 37, and so on. Therefore, this is also arithmetic. This is just an arithmetic sequence. It's actually the sequence for sequence 1 and sequence 2. Therefore, when we're asked which of the above sequences are arithmetic, all three of them are. Question 34. Frida is keeping track of how many coupons she has saved on a piece of paper. She spilled some coffee on the paper. Her list now looks like this, and that black smudge represents where the coffee spill occurred. So she started with 30 coupons. After week 1, she had smudge number of coupons. After week 2, she had smudge number of coupons. And after 3 weeks, she had 240 coupons. So part A says, assume that the sequence of the number of coupons is arithmetic. How many coupons did she have after week 1 and after 2 weeks? So if we started with 30, then week 1 we have X amount, week 2 we have X amount, and then week 3 we have 240. Since this is arithmetic, we know that we are adding plus D, and we're adding plus D, and we're adding plus D, which means that we are starting with 30, and 30 plus D plus D plus D is going to equal 240. So plus 3 D's, and that's going to equal 240. Well, if we solve for D, we're going to subtract 30 on both sides. That's going to give us 3D equals 210. Divide both sides by 3, and D is going to equal 70. This means that week 1, 30 plus 70 is going to be 100 coupons. And then week 2 is going to be 100 plus 70, which is 170 coupons. It is important to be able to show all of your work when you're doing these problems. So please keep that in mind. So even if you can solve it by guess and check, it's important to understand how to solve it using math. Assume that the sequence, this is part B, assume that the sequence of the number of coupons is geometric. So now we're dealing with geometric. How many coupons did she have after week 1 and after 2 weeks? So we're going to start with 30, week 1, week 2, and then we have 240. But because it's geometric, we're multiplying by R, we're multiplying by R, and we're multiplying by R. So what we have is 30 times R times R times R, which is going to give us 240. Well, R times R times R is actually R cubed, which is going to equal 240. So I'm going to divide both sides by 30 to get R cubed by itself. And 240 divided by 30 is 8. Well, then I need to figure out what number cubed equals 8. I can stick this in my calculator as x cubed and go to the table of values, that is second graph, to figure it out. Or I can guess and check, starting with, 1. 1 cubed is 1. Then you can put in your calculator 2 cubed, and we're going to see that it's 8. So I actually know R is 2. Just a quick point to keep in mind when you're studying. Remember that if this exponent is positive, if it's even, R to the 4th, R to the 2nd, you're going to have two values that work, the positive and the negative of that R. So if it had been R to the 4th equals, 16, then positive 2 and negative 2 would work. But to finish this question, after week 1, we have 30 times 2, which is 60 coupons. With week 2, we have 60 times 2, which is 120 coupons. And that's how many coupons we have after week 1 and week 2. Question 35. Look at the graph of the line below. Part A wants you to write the equation of the line in slope-intercept form. So remember, you were given those formulas at the beginning of the worksheet of the exam of the review packet. And so slope-intercept form is y equals mx plus b. Well, we've got to figure out two things here. We need to figure out what m is, and we need to figure out what b is. M stands for slope, b stands for y-intercept. So let's first figure out the slope. There's a couple ways to do this. First of all, we can do it by picking 2 points and doing y2 minus y1 over x2 minus x1. Well, let's say I pick the points here, -2, 1, and I pick this point, 4, 4. Doesn't matter. I could also pick this point 0, 2, but let's just pick A and B. So I'm going to do y2, meaning basically this is going to be my x and my y for B, and this is going to be my x and my y for A. So 4 minus 1 over 4 minus -2. Well, 4 minus 1 is 3, and 4 minus -2 is the same thing as 4 plus 2. So what we really get is 3 over 6, which is 1/2. So our slope is going to be 1/2. Another way to look at this is by doing rise over run. So if I take a point that's on the graph, and you want to pick points that are on the crosses of the lattice marks, so point A, and I do rise, I can see that I'm going up 1 and to the right 2. So positive 1 divided by positive 2 gives me rise over run. Then up 1 over 2, 1 divided by 2, and then up 1 over 2. So that's another way to see that the slope is going to be 1/2. Next, I need to figure out the y-intercept. The y-intercept is where it crosses the y-axis, so that's going to be this point right here, when x is 0. So this is my y-intercept, that's my b, and it's going to be equal to 2. So if I put m and b into my equation, I'm going to get y equals 1/2 x plus 2. And that is my equation in slope-intercept form. Next, we have to write the equation of the line in point-slope form using point A. So they're telling you which point to use. So point-slope form is y minus y1 equals m times x minus x1. Again, you're given the formula on the front of the review packet. So this is going to be y minus, now my a is -2, 1, so y minus 1 equals m. We've already figured out that that's 1/2, parentheses, x minus, and then x1, which is -2. Now, what is minus -2? That's actually positive 2. So I'm going to change this to x plus 2, and there's the equation of my line in slope-intercept form. Point-slope form, using point A. Next, we have write the equation of the line in point-slope form using point B. Again, it's y minus y1 equals m times x minus x1. So we're using point B, which is 4, 4. Therefore, it's going to be y minus 4 equals 1/2, because that's my m, my slope, times x minus 4. And it is as simple as that. Finally, which of the following is the equation of the line in standard form? So I'm going to start with y equals 1/2 x plus 2, because I want my slope-intercept form, and I'm going to put that in standard form. That's the easiest way to do it. Next thing I know, I want all of my x's and y's on one side. I also need my coefficients of my x and y to be whole numbers, not fractions. They can be integers too for y, but x, the coefficient of x has to be positive. So I can either bring all my x's and y's on one side first, or I can get rid of the fraction. I think I'm going to get rid of the fraction first. So to get rid of 1/2, I can multiply that by 2. But if I multiply that by 2, I have to multiply everything by 2. So I'm going to multiply this side by 2, and I'm going to multiply all of this by 2, meaning that I need to use the distributive property. So this is going to give me 2y equals 1/2 times 2 is 1, so x plus, and then 2 times 2 is 4. Next thing, I want to get all of my x's and y's on the same side. So I'm going to bring my x to that side, and I'm going to have negative x plus 2y equals 4. But as I told you, we can't have the coefficient of x be negative. So to get rid of that, I'm going to multiply all of this by negative 1 and all of this by negative 1. So negative 1 times negative 1 is 1, so I'm going to have x. Negative 1 times 2 is negative 2, so I'm going to have negative 2y equals negative 4. And therefore, my correct answer is going to be B. Question 36. Kelly's art teacher is modeling a project for art and algebra. The students are going to create a project with blocks in a pattern. Students will use algebra to describe the pattern. A student puts two formulas on the board. Recursive, f of 0 equals 3, f of n equals 2 times f of n minus 1, and explicit, f of n equals 3 times 2 to the power of n. Part A, using the recursive formula, so they underlined it. Recursive formula above, write the first 5 terms of the sequence. So basically we need to find f of 0, f of 1, f of 2, f of 3, and f of 4. And that's going to give us the 1, 2, 3, 4 first 5 terms of the sequence. Well, we already know that f of 0 is 3, so that's pretty easy. F of 1 is going to be 2 times f of 1 minus 1, which is f of 0. So this is going to be 2 times 3, which is 6. The important thing here is that I'm showing how I'm using the recursive formula to find this. So f of 2 is going to be 2 times f of 1, which is 2 times 6, which is 12. F of 3 is 2 times f of 2, which is 2 times 12, which is 24. And f of 4 is 2 times f of 3, which is 2 times 24, which is going to equal 48. So the first 5 terms of my sequence are 3, 6, 12, 24, and 48. Please don't forget that you're looking for the first 5 terms. That includes our starting term, which is f of 0. Now, part B, you want to know the value of f of 30. Is it more efficient to use the recursive or explicit formula? Explain your answer. So hopefully you know that it's more efficient. We could use either, but it's more efficient to use the explicit formula. So the explicit formula is a more efficient way to find the value of f of 30. Now we need to explain why. So this is because I would have to keep finding the next term in order to finally get the 30th term if I use the recursive formula. Therefore, I would have to find $30 terms in order to get f of 30. Whoops, sorry. With the explicit formula, all I need to do is substitute 30 into the formula for n to get f of 30. So, the explicit formula is a more efficient way to find the value of f of 30. This is because I would have to keep finding the next term in order to finally get the 30th term if I use the recursive formula. Therefore, I would have to find 30 terms in order to get f of 30. With the explicit formula, all I need to do is substitute 30 into the formula for n to get f of 30. Question 37. Julio is filling out his tax return. He needs to report the value of a computer that he bought several years ago for $8,192. He has two options for doing this. Option A, the value of the computer decreases every year, so its value is 3/4 or 75% of its value from the previous year. Complete the recursive formula for the value of the computer using option A. Well, they've already started us out with A of 0 is 8,192, which is our starting value. So then they want us to find A of n. Well, remember, with the recursive formula, we're doing something to the previous term. And because it's decreasing at a rate of 3/4, we're multiplying our previous term by 3/4. So I can have 3/4 times A of n minus 1, or I could say A of n equals 0.75 times A of n minus 1. Either of these answers would be acceptable since they mean the same thing. Then after 2 years, how much will the computer be worth using option A? So we're looking at 2 years, so basically when A of 2, what that equals. So A of 2, now we have to use the recursive rule, is going to be 3/4 times A of 1. But we don't know what A of 1 is. So A of 1 is going to be 3/4 times A of 0. And A of 0 is 8,192. So we're doing 3/4 times 8,192, which is going to be $6,144. So A of 2 is going to be 3/4 A of 1, which is going to be 3/4 of $6,144, and that's going to equal $4,608. So it will be worth, remember to write those sentences, it will be worth $4,608 after 2 years. Option B, the value of the computer decreases by $1,024 each year. Part C, complete the recursive formula for the value of the computer using option B. Well, they've started us off with our initial term, so now all we have to do is see what we do to the previous term. Well, our previous term is B of n minus 1, and we're decreasing, so subtracting $1,024 each year. So b of n minus 1 minus 1024 will equal b of n. After 2 years, how much will the computer be worth using option B? So we started with b of 0. So next we have to find b of 1, which is going to be b of 0 minus 1024. So that's 8,192 minus 1,024. And if we subtract that, we get $7,168. So then to find b of 2, that's going to be b of 1 minus 1,024. So that's 7,168 minus 1,024, and that's going to equal $6,144. So again, I'm going to write my sentence. It will be worth $6,144 after 2 years. Finally, part E. After which year will the value using option A be greater than the value using option B? Complete the table below to answer this question. So what I see is, let's first figure out the table. What we have is A of n, and that's the one where we are multiplying. You're multiplying by 0.75 each time. Okay? So you can use your calculator. You can get 8,192, 6,144. So then we're going to have 4,608. Then we'll have 3,456. And then we'll have 2,592, because I'm just multiplying the previous value times 0.75. So 1,944. 1,458, $1,093.50, and then $820 and 0.125, or $820.13. With B of n, we're subtracting by 1,024 each time. So if we keep subtracting by 1,024, what we see is that we have 8,192, 7,168, 6,144, 5,120, 4,096, 3,072, $2,048, $1,024, and 0. So, we've completed the table. Let's go back and read the question again. After which year will the value using option A be greater than the value using option B? So if we compare, this is the same, but then this is less, 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 less. But then when we get to here, this is actually larger than this value. So our answer is going to be after year 7, option A will be greater than option B. And that does that. Question 38. Use the answer bank below to complete the following statements. So we have the word difference, arithmetic, linear, ratio, exponential, and geometric. Question A. An explicit rule for an arithmetic sequence would be a blank function. So, we know explicit rule in arithmetic also gives us linear functions. Therefore, this would be a linear function. B. The recursive formula f of 0 equals 20, f of n equals 30 times f of n minus 1 represents a blank sequence. Well, because of this times right here, that tells us that it's going to be a geometric sequence, and its explicit rule would be a blank function. Well, we know that a linear and arithmetic go together, so geometric and exponential go together. So its explicit rule would be an exponential function. The sequence 10, 12, 14, 16, 18, 20. So we can see this is adding by 2, adding by 2, adding by 2, and so on, has a constant. Now because this is arithmetic, this is going to be a constant difference of 2. Finally, the sequence 10, 20, 40, 80, 60, where it's multiplying by 2, multiplying by 2, multiplying by 2, multiplying 2, has a constant blank of 2. Well, because it's multiplying, that means it's geometric and therefore has a constant ratio of 2. Question 39. An office is interested in how much recycling occurs. At the beginning of a month, there were 700 pounds of recycled materials. After each day after that, 80 more pounds of recycled materials were added. Let R of D represent the total number of pounds of recycled materials after day D. Complete the table to the total number of pounds of recycled materials. Well, what we can see is that we're adding by 80 every day, and our days are increasing by 1. So let's start with days. We have 0, 1, 2, 3, 4, 5. So 700 plus 780, plus 80 is 780. 780 plus 80 is 860. 860 plus 80 is 940. 940 plus 80 is 1020. And 1020 plus 80 is 1100. So we've completed the table for the total number of pounds of recycled materials. Part B. After which day will there be 1,580 pounds of recycled materials? Show how you determined your answer. So I want to know, when will there be 1,580 pounds? I could continue the table, and we have 6, and that would be plus 80 is 1,180. 7 would be 1,260. 8 would be 1,340. 9 would be 1,420. 10 would be 1,500. So 11 would be 1,580. So we can see that we added by 80 and continued that pattern along, and that's one way of finding out the answer. My only concern with this, sorry, I've run out of space on this side. There we go. My only concern with this is that what if the answer, was 35 days? You'd be continuing that pattern on for a really long time. So it's also important to know how to use the explicit rule. We first have to write it, and the explicit rule is going to be R of D equals our starting amount, which is 700, plus our common difference, which is 80, times the number of D's. So if I want to know what 1,580 is going to equal, I'm going to set that equal to 700 plus 80D. First thing I'm going to do is subtract 700, and that's going to give us 880, and that's going to equal 80D. Then I'm going to divide by 80, and 880 divided by 80, D is going to equal 11. So we can say after day 11, there will be 1,580 pounds of recycled materials. Part C. Well, one quick thing about Part B is just make sure, no matter how you do it, you have to show how you determined your answer. So if you're continuing the table, if you're doing this work, you just need to show your work. All right, Part C. Write a recursive formula for the number of pounds of recycled materials. So they've set it up for you, so you have R of 0 and R of D. R of 0 is going to be our starting amount, which is 700. R of D, we're doing the recursive, so that uses the previous term, so R of D minus 1. And then what we're doing every time is adding the common difference, which is 80. So R of D minus 1 plus 80. Finally, they ask you to write an explicit formula for the number of pounds of recycled materials. Well, we already wrote it up here, but let's go over it again. R of D, we always have the starting amount, which is 700 in this case. And then we're going to add to it the common difference times the number of D's. So 700 plus 80D is going to equal R of D, and that's our explicit formula. Question 40. This is our last question for this review packet. Look at the pattern of small squares below. The number of small squares, n of t, is a function of the time t in minutes. So at t of 0, we have 1. At t of 1, we have 2. At t of 2, we have 4. And at t of 3, we have 8. So we have 1, we have 2, we have 4, and we have 8. Draw the pattern for time t equals 4. So what I'm going to do is I'm going to make a table. That's how I like to figure it out. At time 0, I have 1. At time 1, I have 2. At time 2, I have 4. At time 3, I have 8. And at time 4, I have unknown. So what I can see is that I'm multiplying by 2 every time, and therefore 8 times 2 is 16. So there's two different ways to look at the pattern. What we can see is that after the first one, when we put it to the next, we're then doubling the amount and putting that on top. So once I have 4, I have 8. So one way of writing the pattern is, so I started with 1, and then I had 2, then I had 4. Now double that is another 4. And now I have to double all of this, which is adding on another 8 on top. And we can double check and see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is one way of drawing the pattern for t equals 4. Another way of looking at it is what I can see is that I started with 1 and then added on next to it. Then I added on top and I've got 4. Then I added on top and I got another 4. And then maybe I want to double next to that, and I could write it like this. And again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So either one of these ways is another way of continuing this pattern. Either answer would be acceptable for the exam, although I think this one is more intuitive than this one, but either way works. Part B, complete the tables for times t equals 0 to t equals 7 for the number of small squares. So that's what I had started up here. So for 0, we had 1 square. For time 1, we had 2 squares. Then we had 4, then we had 8. And what we noticed was that we were multiplying by 2 every time. So 8 times 2 gave us 16. 16 times 2 is 32. 32 times 2 is 64. And 64 times 2 is 128. And so we've completed the tables for times t equals 0 to 2 equals 7. Part C asks us to make a graph for the number of squares at time t equals 0 to t equals 7. So basically all we're going to do is plot the points for each of the numbers we found in the table before. So at 0, we had 1. So at time 0, we had 1 square. At time 2, we had 2 squares. which pretty much looks like it's in the same spot. My graph might not be totally accurate because it's a lot harder to write on this than it would be for your own pencil, so just keep that in mind. T equals 2 is 4, so that's somewhere right around there. 3 is going to be 8, which is close to 10. 4 is going to be 16. Oops, sorry. 4 is going to be 16, which is about halfway. Then 5 is 32, so we have to go past 30 a little bit to 32. 6 is going to be 64, so past 60, about halfway between 60 and 70. And then 7 is going to be 128, which is all the way up here near 130. Now remember, these are discrete because we're talking about number of blocks and time. For part D, it asks us to write the recursive formula for the sequence of the number of squares. So it gives us the starting part, so n of 0 is what we started with, and that was 1 block. And then what we did was we found that we were multiplying by 2 to the previous term. So I have 2 times n of t minus 1, and that is our recursive formula. Part E asks us to write the explicit formula for the number of squares. So n of t is going to be our starting amount, which is 1, times our common ratio, which is 2 to the power of t. We also don't need to write the 1 times 2 to the power of t, so you could also write n of t equals 2 to the power of t, and that would be an acceptable answer. Finally, for the last part, part F, is the sequence of the number of squares arithmetic, geometric, or neither? Explain why. Well, hopefully you know because we are multiplying. The sequence is geometric. And this is because you want to use your vocabulary here. Now on the test that we took for this topic, the explanations were a little scattered. You really want to use vocabulary to solidify a good answer. So the sequence is geometric because there is a constant or common constant ratio of 2. Using these words and giving the actual answer will help give you full credit on this. Just saying that we know that this is geometric because it's multiplying is not a good enough answer. So you really want to make sure that you have enough details. So that ends Unit 2, Topic 2, and that actually ends the entire review packet. Please make sure that you study for the exam and really know how to do all of these problems. Practice, 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 and you will be sure to be successful on the actual final exam.